Hello and welcome to this video. Today I will be discussing plastic recycling and polymers. Firstly, I think it's important to discuss why recycling is important. As of 2017, we have produced an estimated 8,300 million metric tons of plastic total as a planet. Approximately 9% of the waste produced from plastics has been recycled, whilst only 12% has been incinerated. The remaining 79% was sent to landfill. This is a serious issue because plastics can be devastating pollutants to our ecosystems. For example, plastics can take upwards of 1,000 years in order to decompose completely. During this time, they could potentially leak toxic substances such as microplastics into the water supply and soil of nearby ecosystems. Microplastics are extremely unhealthy to ingest due to the fact that they can be carcinogenic as well as toxic. Currently, terrestrial microplastic pollution is estimated to be between 4 and 23 times higher than marine microplastic pollution. So it really is an issue that's directly affecting us as a species in our countries. Now that we understand the environmental issues that arise from these problems, let's take a look at what makes a plastic specifically recyclable. The determining factor of what makes a plastic recyclable is how it is made. Thermoplastics can be melted down, reheated, and reshaped fairly easily at a low cost some of the time, whereas thermoset plastics form chemical bonds between the polymer chains during the initial heating and molding. These are called crosslinks. Now, these crosslinks cannot be directly broken under the intense heat of being reshaped and remolded. This makes it extremely difficult to do so. As you can see on this diagram, the polymer chains are bonded, whilst in thermoplastic they are branched. They are not forming bonds between one another, which makes it easier to reshape. You may be thinking that because they can't be reshaped, we should just stop producing these kinds of plastics. Well, they do actually have some specific uses. They can be very good chemical resistors, meaning they can be inert and can be used as plastics for in chemical bottles and things. They are quite tough and can be hard to manipulate, meaning they can provide good structure and can be quite tough. And they're often cheaper than their thermoplastic counterparts, meaning that they are often more economically viable than their alternative. Now, looking at this molecule, I'm going to now show you some plastics that can be recycled. Firstly, this is polyethylene terephthalate. Formed as a condensational polymer between ethylene and terephthalic acid, this is an example of step growth polymerization. I've also highlighted that it has a glass transition state temperature of 70 degrees centigrade. This means that when this polymer is below 70 degrees centigrade, it has a hard and rigid structure, but above it, it's very soft and flexible. Next is polypropylene. Now this is a relatively simple polymer compared to the previous one anyway, in terms of its physical structure. As you can see, it's not aromatic in nature at all, it's just purely aliphatic. However, you may also have noticed that its glass transition temperature is minus 25 degrees centigrade. This is because it requires significantly less energy in order for it to become soft and flexible. The final example that we're going to be looking at are high and low density polyethylene. They have identical monomer units, but a different gross structure as illustrated on the right hand side. Notice how, although the low density polyethylene is branched and spreads out, it does not form any chain links, nor do any of the examples I have discussed here. You may also notice that while the growth structure is branched, the monomer unit is not, unlike the previous monomer we just looked at. One way to distinguish between these two molecules is that high-density polyethylene is opaque, whilst low-density is transparent. The difference in opacity is due to the density of each polymers being so different. High-density polyethylene is, well, obviously more dense, therefore its and this is due to its much more crystalline structure, absorbing light to a greater degree. Now, finally, I think that's important to discuss the environmental impacts of recycling as a whole and whether it's actually beneficial. In the context of a life cycle assessment, expended energies are the energies used and lost in the process of synthesizing the polymer. And this life cycle assessment showed that the expended energies of the virgin plastics, polyethylene, ethylene, I'm sorry, I can't pronounce it. I struggle to pronounce it. But the polymers we've looked at are 1.7, 3, and 3 times greater than that of their recycled counterparts. This means that the recycled plastic has a significantly lower energy process overall compared to producing plastic resins from basic chemicals. To conclude, it's far better to recycle plastics than it is to produce non-recyclable plastics, as it has a much smaller carbon footprint overall. Thank you for watching.